Welcome back, everyone. This is part of Defender. As you can tell, the pandemic is in full flow. I can't get to a hairdresser, so eh. So in this one, we're going to take a look at generating a landscape, but we're not going to use like pen and paper or Photoshop or anything. We're going to try and generate it um, programmatically. So I show you how to do that, but if anyone has any good suggestions about how to generate an actual like nice looking landscape, I get a kind of undulating landscape, let me know in the comments below. But let's get started after the fade. What if we had a script and that script was called landscape generator? And that landscape generator created a texture that was 1280 by 180 at 320 pixels per unit, and we then generate the landscape when we first start the game. When we first start the game. Now, what we'll need is a way to generate a point on a texture along the x-axis. Perlin noise. We don't need an update. So if we have math.perlin noise, yeah, there we go. And then that gives us an x and y value. Is there a 1D? Perlin? No. Well, okay, let's experiment just now. So let's say we want to generate a landscape, but we know that it's going to be like a sine wave. So that's going to be easy to figure out. The sine wave is going to go from 0 to 1, 0 being the where x is 0, and then 1 where x is 1280, because that's going to be the width of the image. So if I have a public I vector, yeah, vertex, yeah, I want that. Public int width equals 1280. Public int height equals 180. Public float units, sorry, pixels per unit equals 320. Okay, so let's scrub this just now, and we need to have private sprite renderer void awake renderer equals get component and sprite renderer, because we're going to change the texture on the sprite render. So I'm going to say texture 2D text equals new texture 2D, and then the width is going to be width, height, texture format, here format dot, does it really matter? Probably not. I mean, we don't need to go crazy here. RGB 565. I mean, it doesn't. I mean, it has to be black, so we have to fill it entirely with black anyway. So we don't need A. So yeah, RGB, that one. MIP chain, I don't know what that is. Do we need it? MIP chain, false. False? I don't know. Okay, and the landscape generator is going to go on the screens. So we have our screens up here. So right now it has a sprite which points to screens. I'm going to delete that just now. So now everything's going to be super trippy because we don't have anything. Whoa. We don't have anything clearing the screen effectively because we're always redrawing that on there. So if I then do renderer dot sprite equals new sprite, actually can I do from create text new rect 0, 0, width height, pivot vector 2.0. I think that's the right one. That should be it. Do I have to set the pixels per unit? Pixels per unit. There we go. All right. Okay. So let me just get rid of the properties thing here so we can see this all in one line. All right. So the idea now is that we'll have a texture and it will be set to be whatever this is here, which is going to be nothing right now. So it's either going to fill it with black because it should be all zeros. That would be my guess, or it's going to fill it with bright white. My guess is it's black. Do you know what would help though? Is if I went and grabbed landscape generator and put it on there. So landscape generator expects a sprite renderer. So this should display black now. Not quite. Oh, that's okay. First off, that's a weird color to default to. Second off, I have the wrong pivot point. So if I go to maximize on play, so if I go to the pivot point for screens, and I go to scene, you'll see that it is down there when it should actually be down here. So the pivot, oh, should it be top? Should be 1. Let me try that. New vector 2. So I think it should be 0, but maybe it should be the topmost. So it should be the top of the vector, the top of the texture. Or maybe we'll just put it in the middle. Maybe that's the real reason. That's the real trick. Okay. Uh-oh. Compile errors. Oh, there you go. 0.5 F. Okay. All right. Okay. So we won't really see any movement. Oh, there you go. Right, so we need to change the Z order. The sort order for that is going to be wrong. Oh, sort 50. So for some reason these guys, lander spawner. These guys aren't showing up. Even though they're in the scene, they're not showing up. So ordering layer. So I change that to 50. Does that make any difference? Nope. Screens. Well, spaceship's showing up. Oh no, there we go. Oh. Oh. Okay, that's just weird. Wait, what? Okay, so if we turn that off, change this back to screen for now. One, two, three, four. Oh, I think, do you know what I think it is? I think it's that they're on the radar before they're actually coming into view, and that's what the problem is. So if I go back to turning that off, delete, and then putting the landscape back on, and then running it, as soon as I move into the next screen, yeah, something weird going on here. All right, let's do the scene generation anyway. Okay, so now that we have that, we need to then figure out for each one of these. So if I do text.get texture array, get raw texture data, set pixel. That one there. What is the best way to do this actually? Text dot read pixels. One moment, please. So yeah, it is just set pixel. I'd forgotten that you need to do the apply after that. So you do for r y equals 0, y less than height, y plus plus, for var x equals 0, x less than width, x plus plus, and then we're just going to set it to black for everything, and then at the very end here I need to do set text.apply, and then we'll do text.set pixel, and then it's going to be xy color.black, and that's it. That's all we do, and then we walk away. Okay. Boom, there we go. Okay, so there's black pixels. So it's still not showing up there for these ones. These ones are okay, but then they disappear. And there's something strange happening with the levels, the sorting layer. Not too sure what that is just now. See, it just seems to kind of see that jump there? That jump is not happening. 1, 2, 3, 4. That's right. Four units. But oh, that's why. Oh, right. Okay, so this should actually be vector 2.half 1. Can I do that? I'm going to try that. Let's see if that works. So that's no, it's not going to be that. Is it vector 1? No, it's not going to be that. Damn it. I need to do new vector 2 5f because it's in the middle, and yeah, okay. All right. Here we go. Okay. Okay. There we go. Okay, there we go. And then this shouldn't be a jump anymore. Yeah, there you go. See, they're coming in. Yeah, there's a problem with the spawn, so I need to put that down in my little list. Aliens in radar before spawn. Okay, but it is looking okay. So that's good. All right. Right. So the landscape, as far as the landscape's concerned, it's going to be at least a third up from the bottom. So a third up from that is 60 pixels up from the bottom, plus another 60 pixels. Let's make it 90 pixels. That could be the difference in there. And then we just do the noise from there. So I'm going to say to find out what color we're gonna set it to be, it's gonna be based on this color here, which is 240. I'm never gonna remember that. 240, 102, 51. 240. See what I mean? 102, 51. Is that 240? 204. Oh, land. Okay. All right. So there's that there, and then we're gonna have we want to do that from the y value. So what's the best way to do this? So the x is going to set the y value, but I don't want to do it for every. Oh, if I do it for every x, it's going to be really costly because it's going to be x, and you're not always going to back over the y. Okay. So we want to check to see the position of the y. So I want to say if y is less than 60, because I don't know what order it is currently in. Color c equals color dot black. If it's less than 60, c equals color dot red. And then we'll change that to c. So if the y value is less than 60 and it's at the bottom, that means it goes from 0 to 1. And if it is the top is red, that means that it goes from 0 to 1. If that makes sense. Okay, so it goes from 0 to 60. Okay. Right. Okay. Right. So if it's 0 to 60, so we want to do, so it's at 60. But we don't know what we're saying. Okay. God, this is difficult, this math. Well, it's not, okay, it's not difficult, the math. The problem is that if we do it by, we're supposed to do it by row and then column. And if we do it row and column, that'll be fast. If we do it column then row, that'll be slow. But mathematically, it works from column to row because you want to get that sine wave graph. Okay, so I'm just going to do this real slow way. So I'm going to say text, clear text. And inside here, I'm going to say, we're going to have this up here. Oops. And again, you can make this like a static extension method, probably work better in your favor. Black, dot black. Okay, I mean this might not actually be too bad because I'm only going to be setting every 1 pixel. So this one's quite fast because it's going row to column rather than column to row. I know I'm obsessing over this, but I think it will work better. And then we want to do for var x equals 0, x less than what do we got here? We've got width x plus plus. Okay, so the proportion along there in radians is going to be that multiplied by 180. Okay, so actually let's just do this. Let's do text.set pixel x comma and then 60 because we know that's the min point, comma new color, and then the color is going to be RGB float, which is 204 divided by 255, 102 divided by 255, and 51 divided by 255. Okay, so we should now have an orange line going right across the screen. Boom, there we go, and it's almost the same color. All right, okay, so 60 seems quite high, so let's do that as the base of 45. So let's say var base equal base landscape y equals 45. Base landscape y equals 45. Okay. And then we need to figure out where we are in the Perlin noise. So we can use var offset equals math if sorry, we want to do the sine wave. So we can say var sine equals math if actually first of all we need to find out where we are in that phase. So we want to say phase equals 180 times x divided by width. That x divided by width, which is going to give me an integer, which is no good. So let me just make that. Let's just make sure that goes into that there, and then we're going to say var sin equals math f times sin phase. And I think it's radians. And it's going to be var offset equals sin times, and then the offset is going to be double the height, which is going to be 90. So we're going to say that equals that, and now this should give us something. Well, it ain't pretty, but it is something, and we can see that it should be infinite. I think it's seamless, so that's good. Okay, let's see what it looks like with Perlin noise, because we might have to kind of tweak some of the values, so that's not too bad. So the Perlin noise is going to be generated by equals math f Perlin noise, and then it's going to be the x and the y. Okay, so x is going to be different, but the y is going to be the same. It's going to be fixed. So we want to keep it fixed. And then that's going to be that. Oops. Okay. So Perlin noise is that's how people generate. That's how you generate landscapes. You know, there's infinite landscapes that you see going into the distance, and difference clouds as well in Photoshop. Those kind of things. That's Perlin noise. There's a couple of good videos about it out there. Coding Train's got one out there on Perlin noise. Okay, well, it's a line. If we multiply it, like float multiplier 20. Let's see if that makes any difference. Maybe it's just too much, or maybe we need to change the y value. I don't know. Let's see what we got. I'm guessing whatever x is and y is. What if we swap them around? So y is different and x is the same. Maybe that'll make a difference. Okay. All right. Okay. One last ditch attempt, and I'm gonna rip off this this person on the internet. Okay. All right. So I found this this interesting article. If I can find it over here. So this is from CodePen. It is written by a chap called Oliver Balfour. So Oliver, thank you for this. So anyway, so he talks about Perlin noise, and it was created by a guy called Ken Perlin. And there's a version of 1D Perlin noise. So I'm gonna shamelessly take this off here, and I'm going to grab his function and that there. Okay. So I'm going to go grab that there. And I'm going to paste this in here. Where are we? Okay. Excuse me. All right, so that's going to be gobbledygook just now. So I put this back up to here. All right. So random is going to be that. All right, I don't need to have that. Okay, I can figure out a random value from that. That's okay. Function interpolate PAPAVX. So that's probably going to be floats. Float. Var private float. Interpolate. What does it not like about that? var that. Return, what was it not like about that? Okay, so I'm going to do float that. Okay, so we're going to lose a bit of precision, but that should be okay. So PA, PB, and PX, what does he use those values for? So he uses that for AB, and then it is A equals B equals rand, y equals that. AB. Okay, and then he multiplies by an amplifier. So he's got an amplifier in here as well, AB. Okay, so let's just try something. So let's do interpolate, and then it will be x base y x. I don't know, something like that. Let's see if it makes a difference. I mean, at this point, I just want something that's gonna be random. I don't really care. It's quite random. Okay, so I think we need to have that as random fully qualify random. Oh, Unity engine dot random dot range 0,1. Okay, so I'm just gonna make it some random value. Hopefully this will do it rather than having it like interpolate, like in a linear interpolation. Well, it's full of stars. This is not how I thought this was going to go. Okay, so let's make that x, and let's make that that. Well, it's a little bit better. I really should look into Berlin noise more, but never mind. Oh, that's a lot better. Oh, what if we make that 45? So what if we make that 45? The thing is that there's this straight one up there. I see, that's not any good. All right, I think we know where we're going with this. I'm going to take some time offline and I'm going to figure out this Perlin noise generator, and then I'm going to come back once again into the breach. There's so much commented out code. Let's get rid of some of this. Okay, so let's get rid of interpolate there, and let's get rid of that there. Okay, so Perlin noise. So this is from, I'm going to put a note in here. C for details. So just to let everyone know that that's where I got this from. That's where it's coming from. So where Perlin equals mathf dot Perlin noise, and then it's going to be x divided by width times 1f. So you need to make it a float, comma 0. and that should give us our purling noise. Let's multiply it as well, times multiplier, just to see if it shifts the needle in any way, shape or form. And if not, I'll be drawing this background. Okay, all right. Okay. And it looks like it continues. It doesn't look like there's any drops in there. That's kind of nice. Okay. So there's that. And then the multiplier. We've got a 90. Can we go that high? Oh. Oh, there we go. Okay. I think that's a success. I mean, it's kind of just doing a kind of undulating hills, but that's kind of what this code says it's going to do, is doing a bobbling thing. So I'm okay with that. I'm going to leave that for other people to figure out. So I'm going to bring the base landscape down to maybe 15, 30. And I think that's good. I think the landscape is good. Yeah, okay, so that's 30, let's make it 15. 15. Actually, let's make it like int base landscape y equals 15. Okay, let's take that there, that to there. Put that there, tidy this up a wee bit, get rid of this, kill that, delete this, text apply. Yeah, we're not doing that, we're only doing text apply once, and then we set that to there. Okay, and we can get rid of all these generic things up here, and I think we have our landscape generated now. I will leave it up to you if you have a better landscape generator for creating just a straight line. And it has to match the seam at the end there, so that the world doesn't end up here and then this side's down here, so that it clashes. So it's got to end up there. If you've got a better generator, leave a comment in the notes below. That would be very much appreciated. And I'm sure everyone else would appreciate that as well, you sharing your knowledge. Okay, so that's okay. I can move these little guys here. And then the next thing is that. All right, okay. Well, again, it's starting to feel a bit defendery, so I'm going to fix that just to get it a little bit more defendery. Yeah, but I'm happy with the progress in the landscape. That's good. We can at least tweak it later on or come back to it at some point. Thank you all so much for watching this video. I really appreciate your viewership, taking time to watch these videos, especially when some of it is a bit painful. But yeah, thank you all for watching. If you like this video, then thumbs up. If you didn't like the video, let me know in the comments below. That would be great. And if you have any suggestions for videos in the comments as well, please, thank you. If you like this and you want timely reminders of when new videos go up, then if you hit the subscribe button and notification bell, then YouTube will do its algo stuff and you will get notified of when I put a new video up. But until then, thank you very much for watching, and I will see you in the next video. Bye bye now.